Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be taking a look at a type of geometric transformation known as translations. Okay, so let's go over the four types of transformations in geometry again, just as a refresher. So there are four transformations in geometry. Okay, and what are they? The four transformations in geometry are 1. Reflections. We have translations. We have rotations and dilations. All right, so how do they differ from each other? So remember that a reflection is basically a flip along a line of reflection, and then a translation is a shift, okay? When you shift a geometric figure on a coordinate system, either horizontally or vertically, that's what a translation is. That's what we're studying today. All right, rotation is a spin around the center, and then dilation is a shrink or a grow. All right, so all these tutorials addressing all these types of transformations are covered in on Mathgotserved.com, so take a look at our playlist if you want to access any specific one. So we're going to be focusing mainly on number 2 today. All right, so just a side point, something to keep in mind is that these first three transformations are known as isometries. All right, what are isometries? Isometries do not alter the shape, the size of the figure. All right, they're known as rigid motion transformations. All right, and amongst the isometries, one is unique, which is the reflection, and this one is unique in the sense that it does not preserve orientation. Does not preserve orientation. So if you take a look at the order of the vertices, when you carry out the reflection, and you look at the order of the reflected figure, you notice that it's changed, all right? Whereas when you have a translation, rotation, or dilation, the orientation remains preserved, okay? So orientation is not preserved with that, but for these guys right here, orientation is preserved. Orientation is preserved. So just a side point to keep in mind, all right? So instructions are for the specified translation. You have to describe the translation verbally, carry out graphically, and then verify your results numerically. All right, so let's say we have a situation. Number 1, we have a triangle WVU with vertices W is -4, -4. V is -5, 0. And U is 0, -2. And then the translation that we're carrying out has the rule xy gets mapped to x plus 5 and y plus 2. All right, so let's go ahead and take a look at the solution to this problem. So let's start by describing the shifts. All right, so the transformation that we have is xy getting mapped to x plus 5, y plus 2. So our shifts, the verbal representation of what we're about to do, are as follows. So think about the direction of the x-axis. The x-axis goes side to side, right? So if you're adding numbers to your x-axis, you're going to be going to the right. All right, the object will be shifting to the right 5 units. And when you're adding numbers to the y coordinate, you're going to be shifting your graph upwards. All right, your geometric figure will shift upwards. So what's going to happen for our shift is we're going to shift 5 units to the right and 2 units up. So this is a verbal description of what we're about to do. So let's carry out the transformation. What we're going to do first is we're going to graph the original figure and then carry out the transformation. Okay, so let's set up our coordinate system. It goes our y-axis and then our x-axis. So let's do the original figure. Let's do that in blue. So W is -4, -4, 1, 2, 3, 4, 1, 2, 3, 4. So that's our W right there. Okay, let's label our axis. This is X and this is Y. And then our V coordinate is -5, 0. So 1, 2, 3, 4, 5. That's our V coordinate. And then our O coordinate is 0, -2. So just go down 1, 2. That's our U coordinate right there. Okay, so let's write them down. So W is -4, -4. V is -5, 0. And then U is 0, -2. Okay, so let's go ahead and connect the points to create our triangle. So triangle, this is triangle WVU coming up right here. Bam, bam, bam. All right, so let's go ahead and carry out the transformation. Now to carry out the transformation here, what we're going to do is we're going to just focus on the vertices, okay? Carry out the shift on the vertices and we should be good to go. So let's start with point W. W, we're going to shift, let's make it blue. We're going to shift, let's make it black, 5 units up. So 1, starting from W right here, 1, 2, 2 units up, 5 units to the right, 1, 2, 3, 4, 5 right here, okay? So you can either go 5 units up, 2 units to the right, or 5 to the right, 2 units up. You end up at the same point. So this point right here is W prime, and we can see the coordinates are 1, -2. Okay, next one is V. We're going to shift it. Let's do 5 units to the right. 1, 2, 3, 4, 5, and then 2 units up. 1, 2. Right here is point V prime. Okay, and we can see the coordinates are 0, 2, 0, 2. All right, and then the last one is U. Let's shoot that 5 to the right. 1, 2, 3, 4, 5, and then 2 units up. 1, 2, right there. Okay, and that's U prime. And as you can see, the coordinates are 1, 2, 3, 4, 5, 5, 0. Okay, so let's go ahead and connect the dots for our final figure, the one that has been transformed. So there you have it right there. Okay, so just a side point, this figure right here, the transformed figure, this is the image under the transformation, okay? And then the one that you started with originally, this right here is the pre-image. All right, so is our answer correct? Yes, no, maybe so. Let's do a check. We're going to use arithmetic to check for the accuracy of our solution right now, okay? So we're going to create a coordinate system, a table of values. So let's see what we have. What we're going to do is we're going to populate the first column the first column with our original points that were given to us. Okay, so point W is -4, -4. Point V is -5, 0. All right, and then point U is 0, -2. So what we're going to do is we're going to apply the transformation rule to these coordinates and then see if they take us to the coordinates that our graph reflects. All right, so now we're going to do some arithmetic. We're going to substitute and evaluate. All right, when we substitute, we're going to have, for the first point W, -4 plus 4 plus 5. So plug in -4 in the rule, transformation rule, and then -4 plus 2. Okay, when you simplify that, you get 1, comma, -2. This point right here is W prime. And then for the V, we have -5 plus 5. So we plug in this -5. See this -5 here? Plug it into that formula right there. So -5 plus 5. And then 0 plus 2 for the y coordinate. We'll simplify that. We have 0, 2. That's V prime. And then the last one, we have 0 plus 5, comma, -2 plus 2. And then for that one, if we simplify, we're going to have 5, comma, 0 for U prime. Okay, so these are our transformed coordinates, x prime, y prime. So now what we're going to do is do a comparison, all right, to make sure we got it correct. So W prime, the arithmetic check says is 1, -2. That's what we have here, correct. And then for V prime, arithmetic check says 0, 2. That's what we have here, check, correct. And then lastly, V prime, U prime is 5, 0. That's exactly what we have here, check. So that shows that our answer is in fact correct, okay? So that's basically how you carry out geometric translations on the coordinate system. Thanks so much for all of you who've been supporting our channel with your likes, comments, and subscriptions. We really appreciate it. If you have any questions about what we just covered, specify it in the comments section below. We'll be more than glad to support you. Tons of support resources can be found at mathgotserved.com or the links in the description below. Thanks again for watching. Have a fantastic day. Goodbye.